Hi, everybody. In this section, we're going to talk about transformation of functions. Transformations are basically when we start with what we call parent function. So usually a basic function that you're familiar with, and then we tweak it. So we tweak it by maybe moving it up or down or left or right on the graph. We tweak it maybe by flipping it around. So maybe flipping it upside down, reflecting it, or we maybe tweak it by stretching it or pushing it either vertically or horizontally. So transformations are when we take a base function we already know, but we make changes to it. And instead of graphing right from the beginning and having to start all the way over and finding all new sets of points, what we do is we can take these little changes and quickly fix the graph. So that's what we're going to show you in these videos here. I'm going to show you about 3 of the main transformations that we see. There are others too, but we'll talk about 3 of the main ones. And I'll show you how to make those quick changes on the graph so you don't have to start over every single time when graphing these functions. So on the first page, what you have, and this is just copied from your text, is or are the images of some popular graphs. So these are graphs that you should be familiar with. And if you're not, that's okay, because you'll be familiar with them now. So your first one obviously is a constant function. So we've seen these just, a plain flat line. You do have, this is an identity function. So an identity function is just linear, but happens to go right through that origin there, and it has a slope of 1. But really any line function, again, you should be familiar with. We have absolute value functions. We have our standard quadratic function, that x squared. We have our standard square root function. This is your cubic. And I know the image on the graph is a little hard to see, but you can probably see it a little bit better in your text. So this is on page 285 of your textbook. And then you have your cubic function, so your cube root. Sorry, this is your cubic, excuse me, your cube root function for this one here. So these are ones that we often use as starting points when we're graphing other types of functions. So these are ones that you really want to be familiar with their starting shapes. So that if you see something similar, you kind of know what it looks like. And we're going to use these a lot in the next coming videos. Now, there are 3 kinds of transformations I'm going to talk about. And the first set are called translations or shifts. So either way is fine, just depends on which textbook you read. Some will call it a translation, others will call it a shift. So these are your simplest kind of transformations. And what's going to happen is you tend to see addition and subtraction as the change to the function. So for instance, let's say you're starting with a basic function. Perhaps you add something to it, or perhaps you subtract something to it. And when this change happens outside of the function, what happens is it shifts the graph either up or down. You can also change and do addition and subtraction inside a function. And when I say inside a function, you can see how in the example here, it's inside parentheses. So an inside change is always inside something, inside parentheses, inside the absolute value symbols, inside a root, inside a denominator. So there's something there where it's contained in something, not just being kind of added to at the end. And when you have a change like this, you actually shift left and right. Now, one thing you want to note, vertical changes are always your outside changes. Horizontal changes, so vertical are things that go up and down. Horizontal go left and right. These are always your inside changes. So what's going to happen is you'll see the change again inside a parenthesis or inside an absolute value or something like that. Your inside changes work opposite to what you would think. So instead of, when you see that plus sign, instead of going right, you actually go left. And when you see that minus sign, that shifts your graph to the right. So let's see some examples. So first, we're going to graph f of x equals the absolute value of x. And then f of x equals the absolute value of x minus 4 on the same grid. Your book doesn't stress this term too much, but parent function here is really that starting function. So as you're graphing transformations, you really do need to recognize what the starting function is. And that's usually one of these functions on the page before, unless the problem gives you something different. Sometimes they may say, oh, use this function to start with. But if not, it's probably one of these. So here, this base function right here, this is your parent function. This is our starting point. And then you can see we're tweaking this by adding in this subtract 4. So what I like to do is actually kind of graph them both. So I'm going to start with that parent function first. Now, from the page before, you should know that the absolute value function looks like this. So we have that, right, that same general idea. The only thing I'm going to do is find some specific points so I can plot it a little bit easier. And again, I'm just going to plug in a few values here. So I'm taking the absolute value. The absolute value of -2 is 2. The absolute value of -1 is 1. And the absolute value of 0 is 0. 1 is 1 and 2 is 2. And we know that the general shape should be pointed, kind of like a V. So my parent function looks like this. And I'm just going to go ahead and extend those lines. There we go. Now, the nice thing too is once you're doing your parent functions, maybe even make your table on your sheet here. So maybe just put that table in of points right next to that parent function so that when you have other problems that are absolute value, you don't have to make those points over and over again. You can just do that the one time. So you can keep track of these values if you find it easier, maybe on this front sheet here or on a note card or something like that. So now I'm going to look at my transformed function. So notice here I'm starting with the original, but I have this -4. And I want you to notice that the -4 is not occurring inside anything. It's just kind of attached at the end. When you have that, you have a vertical change. So that plus or minus is just kind of being attached on the end there. So if it's a -4, it's going to go down 4 units. So this means that we have a shift down 4 units. So what we can do is we take every single point and we just count down 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and so on. And then we can redraw our graph. Oh, sorry, my line's a little bit off there. And there is our transform function. Let's see if I can brighten the screen a little bit. All right, so here is our original function, f of x, and then here is our new function, which we're calling g of x. Now you can make a new table if you want to, so you can always go ahead and do that. But the point of transformations is to try to do the graphing quickly. And with shifts in particular, those are usually pretty quick where you can just kind of visually shift those points on the grid. But if you want to make a table of points, you can still do that. All right, let's do another one that's going to be a shift. So this is my parent function here, my starting function, and it's a square root function. And if you go to the page before, again, the square root function looks like this. So I know the general shape. I'm just going to go ahead and plug in a few points just to make it a little bit easier for myself. Do notice though that your domain here starts at 0, right? We don't want any negatives inside our root. We're not doing imaginary numbers right now. So I can start at 0, and the square root of 0 is 0. If I plug in 1, the square root of 1 is 1. Now I'm going to jump up to 4 because the square root of 4 is 2. And then I like to jump up to 9 because the square root of 9 is 3. So I usually like to pick values that are easy for me to work with. And here's my basic curve. And now I'm going to look at the other one. Notice that it's very, very similar, right? They're both square root functions, but I have this change of this +5. Notice that this +5 is inside the root, right? It's underneath the root. It's contained in something. It's not just being added to at the end. So here we have an inside change, something like this. It's inside something. So if it's a +5, we're going to actually shift left. So we are going to shift left 5 units. And I'm just going to count over. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And then there would be my g of x function. They're going to have the same basic shape, but it's just that we're shifting the graph around here. Okay, let's do one more shift example where we have two changes. So here my parent function is f of x equals x squared. And again, if you need to reference it, that basic function looks like this. So I know it's going to be some sort of U shape to start. And again, for myself, I just like to make a few points here to plot them. And I'm going to just pick -2, -1, 0, 1, and 2. And I'm squaring these values. So -2 squared is 4, -1 squared is 1, and then squaring 0 is 0, 1 is 1, and 2 is 4. So my initial graph looks something like this. Again, I'm just kind of doing just a quick plot here. I know the general shape. I know it's going to be a U shape, but I just want to find a couple more specific points so I can work with them. Now, here I have two changes, but they're both addition and subtraction changes. So I have this +1 here. Notice that that is inside, right? An inside change is always going to be some sort of horizontal change, a left-right movement. And if it's a +1, you can go to the page before if you need to double check. This is going to be a shift left 1 unit. This -3 is obviously an outside change. It's just kind of hanging out at the end. It's not inside parentheses. It's not inside anything. So outside changes are always going to be vertical. And they're going to be very natural. So a -3 is down. So down. So shift down 3 units. So I'm going to take each point. I'm going to apply both of these changes. Now, normally we do inside changes first and then outside changes, or at least vertical shifts at the very end. But we can really just do this all at once because there's not too much else going on. So as long as you can keep track of all your movements, you can go ahead and do these two together. So I'm going to take this point here. I'm going left 1 and down 3. So left 1, down 3. 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 And then I'm going to keep the same general shape though. So it's still going to be that U shape. The shape doesn't change. And there is my new function. Okay. Now I did this in one step. If everything is just a shift, so if it's all adding or subtracting, you can really just do it all together. It's not that it's super easy, but it's not overly complicated as long as you can just keep track of your counting. Once we get into harder examples where we start bringing in multiplication or negatives, multiplying by negatives as well, then I would do things in more than one step and kind of draw each iteration separately. But if it's just shifts, you can apply a couple shifts in the same step and that's fine. If you don't like that, check out the example in your book. On page 289, it goes through the two changes one by one. So first they do that horizontal shift to the left, and then they do the shift down after that. So you can do it that way too. Now, the next set of transformations I want to talk about are called reflections. And reflections, this is your flipping idea. So you're going to flip either down and up or left and right. And what you're going to notice here, how do you know if you have a reflection? You're going to see some sort of multiplication, typically by a negative. So by -1, we'll say. And again, you have two directions here. You have a vertical change and you have a horizontal change. So notice here, see how that negative is outside the function? When your negative is outside a function, so like the whole thing is just being negated, then you have a vertical change here. So you're going to end up flipping in a down up direction. If your change is inside, so notice the negative is inside the parentheses. So it could be inside parentheses, inside a root, inside absolute values, inside a denominator. So inside something, then this is always a horizontal change. So when you flip, you actually flip in a left to right direction. So keep in mind, outside stuff is always up and down. inside changes are always left to right. So let's try some of those. So here my base function is the cubed root of x. And if I go back to it, it looks like this. So I know there's the general shape. I'm just going to pick a few points here to plug in. Okay, and again, I'm going to make my life easy. So I want to think about what cube roots come out even, or come out as integers, I should say. So -8 works. The cube root of -8 is -2, because -2 times -2 times -2 is -8. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1. And then the cube root of 8 is +2. So those are just some good starting values. And again, you don't want to keep doing this over and over again. So take that first page on your own and fill in those tables. So put them right next to the graph. We've done this graph already. We've done this graph. We've done this one. And now we've done this one. So you have starting points for 4 of these already. And then I'm looking at my new graph. And I'm noticing that I see a negative right here. And it's an outside change, right? It's not inside the root, it's outside the root. So your outside changes are always vertical. So what we're going to do is we're going to then flip in an up down direction. All right, so let me draw my graph first, and then we're going to make that flip. So let's see, I have 0, 0, 1, 1, -1, -1, 5, 6, 7, 8, 2, and then 6, 7, 8, 2. Okay, so my graph looks something like this. Now I'm doing a reflection here. So a reflection is a flip, and it's going to be a perfect mirror image, just like symmetry. So I want to perfectly match this, and I'm going in an up and down direction. So here, I'm just going to go down, but if it's 2 up, I'm going to reflect this perfectly. So it's going to be 2 down. So if I'm 2 up here, I'm going to go 2 down here. And then for the next point, if I'm 1 up, I'm going to go 1 down. If you're at 0, 0, you're going to stay there for a reflection. Here, I'm 1 down, so I'm going to make it 1 up. Here, I'm 2 down, so I'm going to make it 2 up. And my new graph looks like this. Now, the other thing you can do, if you find it helpful, is you can find a new set of points here. And there's an easy way, oops, that's too big of a 3. There's an easy way to do that. And all you do is you're going to multiply all the y's by -1. So if you have a vertical change here, let's write that up top here. So what you're going to do is you're going to multiply your y's by -1 in your table. So your x values stayed the same, but this +2 went to -2. This -1, this, oh my goodness, this +2 went to -2. This 1 went to -1. 0 can't be negative, so it just stays. And then here you have the +1 and the +2. So all of those y values end up flipping their signs to get that reflection up and down. Let's do one more reflection. So here we have our square root function. And we already did this one, so I'm just going to quickly rewrite some of our points. So we did 0, 0, we did 1, 1, we did 4, 2, and we did 9, 3. Right, so once you have those points, save them. Don't throw away your work, because you're going to need them for other examples. And then now we think about the transformation. So notice here that that negative is inside. So you're going to end up flipping this in a left-right direction. So a horizontal flip. Here it's on the right, so it's going to flip left. You just do the opposite. And you want to do it with symmetry. So make sure it's a perfect flip. So the 0, 0 can't really get flipped. It's going to stay. But this point here, if it's 1 on the right, it's going to move to 1 on the left. Here we're 1, 2, 3, 4 on the right. So we're going to move 1, 2, 3, 4 on the left. Here we're 9 on the right. So we're going to move 5, 6, 7, 8, 9 on the left. Okay. If you're having trouble seeing that, what are you going to do to your table? Well, you're going to multiply your x's by -1. That's what's happening when you have a horizontal reflection. So notice that the y values all stayed the same, and all those x values got multiplied by -1. So that's the change that you can see. If you're having trouble doing it visually, you can always do it with your table. So again, I'm going to just take a pause here and add that in. So we end up multiplying our x's by -1 from the original parent function. That's the change that we see there. All right, so those two, I don't want to say they're easy because they're not. Transformations can be pretty tough until you get used to them. You want to really practice with these and look out for what kind of change you're looking for. These two tend to be a little bit easier than the last one we're going to do, and I'll do that in the next video. So far, just to kind of recap, we have our shifts. So for shifts, you're always going to see addition or subtraction changes. And then we just saw our reflections. And for reflections, you're always going to see some sort of negative. So you're multiplying something by a negative, and that's going to be your reflection.